Welcome back. In this video I'm going to be giving a basic overview between the differences between a series circuit and a parallel circuit. Ta-da! Now the difference between a series circuit, or the main differences, is in a series the voltage is going to drop across this resistor and then drop again across this resistor, but the current around this whole mesh or loop or circuit thing is going to remain the same. In parallel, the voltage between these 2 points is going to stay the same. However, this time the current is going to be the one that changes. So to summarize, in series the voltage is the one that splits, whereas the current around this whole loop is going to be the same. Whereas in parallel, we can think of this as like water coming into two pipes and splitting evenly. If these were even resistors, it would split evenly. It's not necessarily going to otherwise. But the two streams are going to split up and then combine back into this mega stream at the end. However, the voltage or the pressure, if you want to think of it that way, is going to be the same between this point and this point, regardless of how many rows we have in here. This is of course assuming that we have an ideal power source, which I won't go into too much depth. But yeah, basically the current in this case is the one that splits, and the voltage is the one that stays the same. Just an example in the real world, if these were, say, two circuits of Christmas lights, if we were to make a cut in here, then none of these Christmas lights would work because there's no closed loop for any of the current to flow around. Making a cut in one place kills the circuit everywhere. However, in the parallel circuit, if we were to make a cut here, then we'd still have current that was able to flow around this part of the circuit. So in a parallel circuit, just because this light's got a disconnected lead or something, the rest of the circuit can still function normally. Now that we know the difference between that, I'm just going to overview some of the three most basic, in fact, circuit elements that you'll see in a DC circuit. First one, of course, is our resistor, which we're all too familiar with. It's got that sort of symbol, the zigzag. You call it R, and a resistor is measured in ohms. Another circuit element you may see is an inductor. Now the inductor has a funny character, L, and it's measured in henrays, which is just H for short. Finally, the last basic circuit element you'll see is a capacitor. So capacitor has the symbol C, and the units for capacitance is farads, which can be abbreviated to an F. You might even hear the abbreviation RLC circuit, which just means the circuit contains these three passive circuit elements. Passive meaning they only suck in power, they don't produce anything. So now to simplify, say you had two resistors in series. The rules for adding them, say this was one, we could add these two resistors and make them into a simplification of this circuit, whereby the equivalent resistors on this one is just going to be 1 plus 1. Or the value of this resistor plus the value of this resistor. If this was a 2, this would be 1 plus 2, and the total thing would be 3. But in this case it's 2. The rules are not the same for parallel. In parallel it's a little trickier in that, say you had two resistors again in parallel, say this was 1 ohm, should really write the units, but hopefully you get it, 1 ohm and 1 ohm. If we wanted to convert this into an equivalent resistance, we would use the formula Req equals R1 times R2 over R1 plus R2. So in this case, it's going to be 1 times 1 equals 1 times 1 over 1 plus 1, which I hope you know is 2. So that's going to be 1 times 1 is 1, 1 plus 1 is 2. So our equivalent resistance, Req, is going to be 1/2 or 0.5. And that's of course measured in ohms. Now the exact same applies if each of these elements was an inductor. You add resistors and inductors in exactly the same fashion. The only difference is instead of saying R, you say L, and instead of saying ohms, you say henries. That's really the only difference, at least with adding them. An inductor is not the same thing as a capacitor, but when you're adding them, you use the same rules. Now for a capacitor, the capacitor is sort of like the black sheep in that the rules are the same except they're reversed. So say you had two capacitors and they were in series. If we wanted to convert this into a single capacitance, we would say, let's say this was 2 farads and this was 3 farads. Don't worry if these units are confusing. Just it really only matters about the numbers at this point, because yeah, you'll eventually learn them, but they can be confusing to start with, which is why I'm omitting them. But the equivalent capacitance in this case is going to be 2 times 3 over 2 plus 3, which is going to be 6 over 5 equals 1.2, and that's measured in farads. So that capacitor there is 1.2 farads when the capacitor is in series. Capacitors are in series. If we had those capacitors in parallel, it would be simpler. We'd just use capacitor 1 plus capacitor 2. So say that was 2 farads, this was 3 farads, and this can easily be converted into a single capacitor, where this capacitance is just 2 plus 3, or 5 farads. This has been a really basic introduction to, or overview really, of some of the basic circuit elements you'll see and how you combine them. I hope this video has made some sense, and as always, thanks for watching.